Welcome, traveler of thought and dream, to science, to sleep by. Tonight, we drift far beyond the bright lights of Earth and sail into the ancient silence of the cosmos to witness one of the universe's most beautiful secrets, the quiet birth of galaxies. In this journey, we'll listen to the whispers of time itself, how gravity sculpted the first islands of stars, how darkness gave rise to light, and how, even now, the universe continues its slow, serene creation. So lie back, close your eyes if you wish, and let the sound of science guide you beyond the edges of our night. Keynote 1: The Cosmic Dawn. When darkness learned to glow. Story of the cosmos begins not with brilliance, but with silence. A silence so deep, so endless, that it filled everything. In the beginning, there were no stars to light the void, no galaxies to scatter their luminous arms across the abyss, and no colors to paint the canvas of eternity. There was only the cold whisper of expansion, the quiet murmur of particles drifting apart in the infinite night. The universe was young, only a few 100,000 years old, and it was wrapped in darkness so complete that even the memory of light seemed impossible. Yet within this great stillness, a faint rhythm began to form, a pattern that would one day become everything we know. After the Big Bang, the universe expanded rapidly, its energy stretched thin across the growing void. As it cooled, protons and electrons found each other, forming simple atoms of hydrogen and helium. The cosmos, once a seething fireball of radiation, became transparent. Light could finally move freely, but there were no stars to shine it. The universe had become a dark ocean, filled with invisible gas, serene, yet pregnant with the promise of something extraordinary. This was the age cosmologists call the cosmic dark ages. If you could have floated there, suspended in that silent expanse, you would have seen nothing. No glow, no spark, only a faint afterglow from the Big Bang itself, fading into the distance. Space was cool and calm, but beneath that calm lay invisible ripples, small differences in density, tiny imperfections in the smoothness of matter. These ripples were the first signs of destiny. They were the seeds of galaxies, planted by the physics of the early universe. Gravity, the quiet architect of all structure, began to work its patient art. Imagine gravity not as a force that pulls, but as a gentle sculptor, shaping the invisible clay of the cosmos. Where matter was slightly denser, gravity pulled more strongly, gathering hydrogen into larger and larger clouds. The process was slow, delicate, and utterly silent. Over millions of years, the invisible hand of gravity guided gas into knots, filaments, and vast clusters. These invisible forms were the first blueprints of what would one day become the grand cosmic web, the network of galaxies stretching across billions of light-years. At first, these gatherings were small, fragile things. The universe was still expanding, trying to tear them apart, but gravity was patient, and time was on its side. The densest regions became slightly warmer, their atoms colliding more often, their energy rising. Deep within these clouds, pressure began to build, like the heartbeat of something waiting to be born. This was the slow ignition of cosmic dawn, not in bursts or flashes, but in the whisper of atoms finding one another in the dark. In these early moments, nothing seemed to change. For hundreds of millions of years, the universe remained cloaked in its dark veil. But within the densest clouds, hydrogen began to compress under its own weight. The heat grew, the pressure increased, and eventually, fusion began. The transformation of matter into light. The first stars flickered into existence, faint at first, then brighter, until their radiance pierced through the cold fog that had filled the cosmos for eons. When those first stars ignited, the darkness that had reigned since the beginning finally learned to glow. The cosmic dawn had begun. These first stars, called population 3 stars by astronomers, were unlike any stars we see today. They were giants, massive, hot, and short-lived. Many of them burned through their fuel in just a few million years, compared to the billions of years that modern stars endure. Yet in that brief time, they changed everything. Their light began to ionize the hydrogen gas that surrounded them, turning opaque clouds into transparent space. Their nuclear fires created the first heavier elements: carbon, oxygen, iron, the building blocks of everything that would come later. The light from those stars spread across the universe, igniting other regions, inspiring new waves of creation. From one cluster to another, gravity wove its web tighter, pulling stars together into small galaxies. The first galactic seeds were born in silence, under the glow of those ancient suns. The universe, for the first time, shimmered with the light of its own making. If you could watch this unfold, it would not be a sudden explosion of color, but a slow illumination, a spreading dawn that crept gently across space. Each star that formed added a note to the cosmic symphony. The once black void became a tapestry of faint, scattered light. The galaxies that would one day hold billions of stars were still only glowing embers, barely visible, but their presence marked the beginning of order and chaos. The cosmic dawn was not just a transformation of matter, it was a transformation of meaning. It was when energy began to tell a story, when the universe began to organize itself into beauty. Before this era, there was only entropy spreading evenly, a calm monotony without pattern. But when stars began to form, complexity was born. The universe started to build, to evolve, to think in its own quiet, natural way. And though billions of years now separate us from that time, we can still see its traces. The faint radiation from those early stars has traveled for eons, stretching with the expansion of space, cooling into invisible microwaves. We call this the cosmic background, and within its delicate patterns are the fingerprints of that first awakening. It tells us that the universe, even in its earliest silence, was already humming with potential. In the poetic stillness of the cosmic dawn, something profound happened, the transformation of nothingness into light, of simplicity into structure. From the emptiness of hydrogen gas emerged the first fires of existence. And those fires carried within them the seeds of everything. The stars, the galaxies, the planets, the atoms in your blood, the thoughts in your mind. Every spark that burned in that distant era set in motion a chain of creation that would one day lead to us watching the night sky and wondering how it all began. Astronomers today use powerful telescopes to look back in time, capturing the light from those earliest stars and galaxies. They peer across billions of light years to witness the moment when darkness first surrendered to illumination. Each photon they detect has been traveling since that ancient dawn, crossing the cosmic sea for over 13 billion years to tell us its story. And in every flicker of that light, we hear the same message, that the universe was once a quiet place, waiting patiently to wake. The silence that once filled the cosmos still echoes between galaxies today. Even now, in the faint hum of background radiation, in the soft glow of starlight stretching across the void, we can sense the memory of that first awakening. The universe may have begun with noise and heat, but its beauty was born in stillness, in the patient, silent gathering of matter, in the slow birth of the first stars, in the quiet dawn that taught darkness how to shine. The cosmic dawn when darkness learned to glow remains one of the most delicate and wondrous chapters in the story of existence. It is a reminder that creation often begins not with chaos, but with calm, not with thunder, but with a whisper. The galaxies, the stars, the light that fills our night sky, all of it was born from the gentle unfolding of the universe's first breath. In the soft silence before time itself began to sing, in the vast stillness of the young universe, there was a single force that began to weave order from chaos. It was not loud, nor violent, nor immediate. It was patient, persistent, and invisible, a quiet hand shaping everything we know. That hand was gravity. From the first moments after the Big Bang, gravity began its long and delicate labor, drawing together particles of matter that floated through the expanding void. Though faint and almost imperceptible, its pull never ceased, never tired, and never faltered. Over billions of years, gravity became the sculptor of creation, the artist behind every galaxy, every star, every world that would ever exist. To understand the role of gravity in the birth of galaxies, one must imagine the early universe as an ocean of hydrogen and helium gas. These elements, born from the Big Bang, were scattered almost evenly, yet not perfectly. There were small ripples, places where matter was just a little denser than its surroundings. Gravity noticed these tiny imperfections. Where there was slightly more matter, gravity's pull was just a little stronger. It began to draw in more gas, more particles, until the small differences grew larger. The process was slow, subtle, and relentless. Over time, the smooth universe began to ripple and fold. As invisible hands gathered matter into filaments, knots, and clouds, unlike the explosive events that would later define cosmic history, supernova, collisions, and radiation bursts, this stage was almost silent. Gravity did not shout. It whispered. Its influence spread not through violence, but through patience. In the emptiness of space, it called to every atom, pulling it toward the promise of connection. The laws that governed this quiet process were simple but profound. The more matter collected in one place, the stronger its pull became, which in turn attracted even more matter. It was a self-reinforcing cycle, a cosmic gathering that slowly transformed the void into structure. Imagine billions of years passing as if they were heartbeats of the universe. Vast clouds of hydrogen began to fall inward under their own weight, growing denser and warmer as gravity compressed them. These were not yet stars, not yet galaxies. They were the blueprints, the rough sketches of creation. Inside them, the pressure increased, and in their cores, energy began to stir. The balance between gravity's inward pull and the gas's outward pressure defined their destiny. When the pull grew stronger than resistance, collapse became inevitable. The first stars would ignite soon after, but before that light arrived, gravity was already orchestrating the dance. The scale of this work is beyond imagination. The distances were measured not in miles or kilometers, but in light years, billions of them. Yet across those incomprehensible expanses, gravity acted with perfect precision. It connected regions of the universe separated by unimaginable distances, ensuring that structure would form everywhere. Even as space expanded, stretching the cosmic fabric outward, gravity worked to bind small parts of it together. It was the counterbalance to expansion, the force that whispered, "Come closer," in a universe that wanted to drift apart. If we could have watched this process unfold, it would have looked like mist gathering into clouds, clouds merging into filaments, and filaments converging into luminous nodes. The seeds of galaxies. These early formations were fragile, shaped entirely by the invisible gravity of matter, much of which was not even ordinary. Most of the mass that guided this creation was dark matter, a mysterious substance that neither emitted nor absorbed light, yet made up the framework of the cosmos. Dark matter formed immense halos, like invisible skeletons, around which galaxies would later grow. Ordinary matter, the hydrogen and helium gas, fell into these halos, settling into the gravitational wells they created. Without this dark scaffolding, galaxies as we know them might never have formed. Gravity did not only gather matter, it also gave birth to motion. As gas clouds fell inward, they began to spin, conserving angular momentum. This slow rotation would become one of the most important features of galaxies. Over time, the spinning gas flattened into disks, and within those disks, stars would one day form. The spiral arms of galaxies, those magnificent swirling patterns we see in the night sky, owe their existence to this gentle rotational motion, first guided by gravity's hand. It was as though the universe had begun to learn rhythm, the soft rotation of creation, the slow turning of eternity. Every star, every cluster, every galaxy we see today was shaped by this same quiet principle. Gravity did not create them instantly. It took eons. It gathered matter, allowed it to cool, let it collapse, and then balanced it delicately with energy from fusion and motion. In this way, it became the great moderator of the cosmos, maintaining equilibrium between order and chaos. The stars born within its embrace would later die in explosions, scattering heavier elements back into space, only for gravity to collect them again and form new generations of stars. Creation, destruction, and rebirth, all bound by the same gentle pull that began in silence. Even today, in the modern universe, gravity continues its timeless work. It holds the planets in their orbits, binds galaxies into clusters, and connects those clusters into vast cosmic webs stretching across the observable universe. The same force that once pulled together the first wisps of hydrogen now keeps your feet on the ground, anchors the moon around Earth, and steers the dance of entire galaxies across the dark ocean of space. It is a reminder that the smallest and the greatest are united by the same invisible thread. Astronomers studying distant light can still trace gravity's signature in the way galaxies bend the light of those behind them. This bending, called gravitational lensing, reveals the hidden architecture of the cosmos, the invisible hand still at work, shaping the view we see from Earth. Through this lens, we can glimpse the web of dark matter that spans the universe, an unseen network glowing faintly through its gravitational influence. Every curve of light, every distorted star image, is gravity's fingerprint, a testament to its enduring artistry. If the universe were a symphony, gravity would be the conductor, keeping harmony between expansion and collapse, between light and dark. Its tempo is slow, almost imperceptible, measured not in seconds or minutes but in eons. Yet its influence never fades. Even the grandest explosions, the deaths of stars, the collisions of black holes follow its lead. The very space-time fabric itself ripples with gravitational waves, silent echoes of cosmic motion traveling across billions of light years, whispering the story of movement and form. And perhaps the most poetic truth about gravity is that it does not act through contact or touch. It works across emptiness, binding what is separate, connecting what is distant. It is the ultimate expression of unity in a universe that began as chaos. Where everything once drifted apart, gravity brought belonging. It transformed isolation into structure, emptiness into galaxies, and randomness into order. It is not the loud fire of creation, but the quiet hand that guided it, the sculptor that turned the void into a masterpiece. From the first whisper of cosmic gathering to the spinning arms of modern galaxies, gravity has been the unseen force shaping everything that exists. Without it, there would be no stars to shine, no planets to orbit, no life to wonder about it all. The universe owes its form, its rhythm, and its beauty to this gentle architect. The galaxies we gaze upon in the night sky, glittering like jewels scattered across eternity, are the enduring sculptures carved by gravity's patient hand, the silent masterpiece of the cosmos in motion. There comes a moment in every story of creation when darkness begins to tremble, when silence meets the first vibration of sound, and when stillness gives way to light. In the story of the cosmos, that moment was the birth of the first stars. It was not a sudden explosion filling the heavens, nor a loud unveiling of light. It was a quiet ignition, the faint beginning of brilliance in a sea of eternal night. These first sparks of light were the universe's earliest expression of creativity, the transformation of cold hydrogen clouds into radiant spheres of fire that would illuminate the void for the first time. Before this dawn, the universe had been a vast, dark expanse of cooling gas. For hundreds of millions of years after the Big Bang, matter drifted quietly, guided by the soft hand of gravity. Slowly, hydrogen atoms began to cluster into denser pockets, forming enormous clouds that stretched across hundreds of light years. These clouds were the silent wombs of the first stars, places where gravity's pull grew strong enough to overcome the pressure of the gas trying to expand. Within these collapsing clouds, nature's simplest element was about to perform its most extraordinary act. Deep inside those cosmic cradles, the process of star formation began. As gravity pulled the gas inward, the density at the center increased. Atoms collided more frequently, and with each collision, trace of heat built up. The temperature rose, and the cloud began to glow faintly in infrared light invisible to human eyes, but a sign that something monumental was beginning. The pressure and heat grew together, locked in an ancient balance. For millions of years, the gas continued to fall inward, spiraling and compressing until the temperature in the center reached tens of millions of degrees. And then, quietly, but irrevocably, fusion began. In that instant, hydrogen nuclei collided with such force that they merged, forming helium and releasing an immense amount of energy. The core of the collapsing cloud became a furnace, its pressure suddenly balanced by the outward push of radiation. The first star had ignited, and the universe, once silent and dark, began to shimmer with the light of its own creation. These first stars were unlike anything we see today. Astronomers call them population 3 stars, the pioneers of the cosmos. They were massive, far larger than our sun, some hundreds of times its size. Because the early universe contained only hydrogen and helium, these stars were pure, untouched by the heavier elements that would later enrich galaxies. Their immense size made them burn fiercely and briefly, living only a few million years before ending in spectacular deaths. But during their short lives, they changed everything. Their light streamed out across the cosmos, piercing the darkness that had blanketed space since its beginning. Each star became a beacon, a signal that the universe was no longer asleep. The photons they released traveled freely, heating and ionizing the surrounding hydrogen gas. The once neutral atoms of the universe were torn apart by this radiation, creating vast bubbles of ionized gas that spread outward like ripples in a cosmic pond. This great transformation is known as reionization, the process by which the universe's darkness was slowly lifted. If you could have seen this unfold, it would have been a breathtaking sight. Imagine a canvas of infinite blackness, slowly dotted with faint glimmers of light. Each spark grew into a glow, each glow into a cluster, and soon the darkness itself began to shimmer. There was no sound, for sound cannot travel through the vacuum of space, but there was rhythm. The rhythm of fusion, of light spreading and illuminating the cold. The birth of the first stars was not a violent roar, but a serene awakening, a gentle unveiling of brilliance in places where only shadow had reigned. Inside these stars, the universe began to craft the elements of life. In their blazing cores, hydrogen fused into helium, and helium fused into heavier elements like carbon, oxygen, and nitrogen. When the most massive of these stars reached the end of their brief lives, they exploded in supernova, scattering their enriched contents into space. The debris from those explosions became the raw material for future generations of stars and galaxies. Every carbon atom in your body, every molecule of oxygen you breathe, was once forged in the heart of a star that lived and died billions of years ago. These first stars were not only the bringers of light, they were the forges of everything we are. The radiation from these early giants reshaped the cosmic landscape. It heated the interstellar medium, altering the formation of future stars. It also provided the first feedback loop in the universe's evolution, light influencing matter, matter guiding gravity, and gravity birthing new stars. The delicate balance between these forces became the foundation for all cosmic architecture that would follow. Even as the first stars burned out, their energy lingered, their influence extending far beyond their short lives. Astronomers today look for the light of those first stars using powerful telescopes like the James Webb Space Telescope. Because light travels at a finite speed, to look deep into the cosmos is to look back in time. The faint red glow captured by such instruments carries the imprint of those first luminous moments. We cannot see the stars themselves, they lived too long ago and too far away, but we can detect their fingerprints in the light they left behind. Their radiation altered the chemistry of space, leaving subtle patterns that scientists can still read. These patterns tell us that even in its infancy, the universe was already becoming complex, already filled with movement and transformation. The first stars gathered in small groups, bound together by gravity into what would become the first proto-galaxies. Within these clusters, new stars formed from the ashes of the old, each generation richer in elements than the last. This ongoing process of birth, death, and rebirth transformed the universe from a simple sea of hydrogen into a dynamic, evolving tapestry. The light from these early clusters began to blend, softening the sharp contrast between dark and bright, turning the early cosmos into a luminous haze. From this haze, the first true galaxies emerged, swirling collections of stars, gas, and dust held together by gravity. But the first sparks had already done their work. They had ended the cosmic dark ages, begun the process of element creation, and seeded the path for everything that would come next. The birth of the first stars was the moment when the universe began to express itself through light, when matter learned to shine, and when the quiet rhythm of physics gave way to the poetry of creation. Even now, when we gaze at the Milky Way stretching across the night sky, we are seeing the descendants of those ancient lights. Every star we see is a continuation of that original story, a reflection of the first fires that burned in the deep past. The atoms in our world, the iron in our blood, the calcium in our bones were once part of those first fusion reactions that began billions of years before Earth existed. The stars, in their silent birth, carried within them the potential for life, consciousness, and wonder. The first sparks marked the turning point of the universe's narrative. From simplicity to structure, from darkness to light, from lifeless gas to creative flame. It was the moment when physics became poetry, when gravity's patient gathering met energy's explosive release. The universe, having waited in shadow, now began to glow from within. These first stars were the breath of creation, the gentle flicker that transformed the void into a living cosmos. The first light that taught the universe how to shine. When the first stars began to burn, their light was a signal that the universe had changed forever. The silence that had ruled the cosmic darkness was now broken by a soft radiance, and with that glow came the next great chapter of creation, the gathering of giants, the slow and graceful formation of galaxies. The stars, though magnificent on their own, were never meant to exist in isolation. Gravity, patient and unyielding, began to draw them together, weaving the first grand patterns of structure into the vastness of space. From scattered points of light came something larger, something enduring. The first galaxies, the true architects of the visible universe. The story of galaxies begins with the smallest of gatherings. After the first stars ignited, they clustered together within clouds of dark matter, the invisible scaffolding that shaped the universe. These clusters, called proto-galaxies, were chaotic and fragile. They were small collections of stars bound loosely by gravity, swirling within halos of invisible mass. Over millions of years, these early structures began to merge, drawn toward each other by the same quiet force that had birthed them. What began as small islands of light slowly merged into larger, more defined systems, each collision shaping the destiny of countless stars. In these ancient mergers, gravity was both artist and engineer. It pulled, twisted, and sculpted the chaos of early matter into elegant forms. Clouds of gas collided and compressed, triggering waves of new star formation. Every impact, every gravitational embrace, became a catalyst for creation. Yet the process was slow, unimaginably slow, unfolding over hundreds of millions of years. Galaxies did not form in sudden bursts. They grew as living systems, breathing and evolving with each new encounter. The universe was no longer a silent void, but a great cosmic workshop, where gravity and time collaborated to forge complexity from simplicity. The early galaxies were very different from the grand spirals and ellipses we see in the night sky today. They were irregular, clumpy, and turbulent, their light flickering unevenly through clouds of gas and dust. They were the children of chaos, learning the language of balance. Each merger, each gravitational interaction, helped to smooth their form, teaching them structure. Over time, rotation began to define them. The clouds of gas and stars, pulled together by gravity, started to spin, flattening into vast disks. In these disks, the seeds of spiral galaxies were planted, structures that would one day fill the cosmos with breathtaking beauty. The spinning motion of galaxies is one of the universe's most poetic expressions of balance. It is the quiet equilibrium between the inward pull of gravity and the outward motion of stars. This balance is what keeps galaxies stable, allowing them to persist for billions of years. The stars within a galaxy do not simply fall toward its center. They dance in orbit, each one following a path carved by the collective gravity of all the others. This dance is both ordered and eternal, a cosmic choreography that began when the first giants took shape in the deep past. The gathering of galaxies also brought about diversity. Some became majestic spirals, like our own Milky Way, with arms gracefully curving around their bright centers. Others became elliptical massive, smooth ovals of ancient stars that had long since ceased forming new ones. Some remained irregular, shaped by turbulence and collisions, never settling into symmetry. Each form told a different story, reflecting the history of its creation, how it merged, how it rotated, how it evolved. The variety of galaxies across the universe is a testament to nature's endless creativity, sculpted by the same laws but expressed in countless ways. In the early universe, these galaxies were closer together than they are today. Collisions were common, though not destructive in the way one might imagine. When galaxies collided, their stars rarely touched. Instead, their gravitational fields intertwined, distorting and reshaping their structures. Gas clouds within them compressed, igniting new generations of stars. Each collision brought renewal, old stars aging and dying, new ones bursting into existence. It was through this slow, graceful merging that galaxies grew larger and more luminous. As they evolved, the centers of many galaxies began to develop something extraordinary: supermassive black holes. These cosmic giants, millions or even billions of times more massive than the Sun, became the gravitational hearts of their galaxies. They pulled surrounding matter into swirling disks, heating it to extreme temperatures and releasing immense energy. For a brief time, some galaxies shone with a brilliance greater than all their stars combined, becoming what astronomers call quasars. These luminous beacons marked a new stage in galactic evolution, a phase when galaxies themselves became engines of light. But not all galaxies grew in the same way. Some remained small and dim, orbiting larger galaxies as satellites. Our Milky Way, for example, is surrounded by dozens of such dwarf galaxies, remnants of earlier epochs, relics of the time when the universe was young. Others grew vast and ancient, becoming elliptical giants containing trillions of stars. In their diversity, galaxies mirrored the complexity of life itself, each unique, each following its own path, yet all born from the same cosmic laws. The formation of galaxies also brought a new kind of structure to the universe as a whole. Under gravity's guidance, galaxies gathered into clusters, and those clusters formed even larger superclusters, connected by filaments of dark matter and gas. This immense web of galaxies stretched across billions of light years, creating a cosmic architecture that remains visible even today. The night sky, though it seems scattered and random, follows the same pattern: a vast network of connections shaped by gravity's invisible touch. As galaxies matured, they began to nurture planets. Within their swirling disks, dust and gas clumped together, forming stars with planetary systems. The heavy elements created in earlier generations of stars, carbon, oxygen, iron, were recycled into these new worlds. It was in these galaxies, and only because of them, that life became possible. Every planet, every living creature, every thought that ever existed can trace its origin back to the gathering of galaxies. They were not just collections of stars, they were the cradles of possibility. If we could look back across the ages and witness this gathering, we would see a universe in motion: galaxies drifting together, colliding, merging, glowing, and evolving. We would see gravity performing its timeless art, turning random clouds of gas into luminous spirals, shaping the chaos of creation into elegance. We would see the cosmos learning to organize itself, to build complexity, to grow from scattered sparks into structured beauty. The formation of galaxies was not merely a physical process. It was the emergence of pattern, the moment when the universe began to resemble itself: a living, expanding masterpiece of balance and harmony. Even today, billions of years later, the gathering continues. Galaxies still collide and merge, though the universe has grown vast and the spaces between them wide. The Milky Way itself is on a slow, inevitable collision course with the Andromeda Galaxy, a dance that will unfold over the next several billion years. When they finally merge, their stars will swirl into new formations, and their black holes will unite in a burst of gravitational waves that will ripple across the fabric of space-time. It will be the continuation of the same story that began so long ago: the story of gathering, shaping, and transforming. The gathering of giants, the formation of galaxies, stands as one of the most majestic acts of cosmic evolution. From scattered stars to vast structures containing billions of suns, gravity wove its quiet masterpiece. Every glimmering arm, every spiral, every cluster we see in the deep sky is a chapter of that story, a record of how the universe organized itself from chaos into order. The galaxies are not just the background of existence. They are the stage, the actors, and the story all at once. Within them, time and space found meaning, and the quiet universe learned how to build, how to shine, and how to create worlds long before the galaxies took their elegant forms. Before light filled the cosmic night, something unseen was already at work, quietly shaping the destiny of the universe. It was not light, nor gas, nor anything that could be touched or measured by the instruments of early astronomy. It was something invisible yet overwhelmingly present, a hidden framework upon which all visible matter would rest. This unseen force, this ghostly substance, is what we call dark matter. It is the silent architect of creation, the invisible web that has guided the formation of galaxies since the dawn of time. Though we cannot see it, everything we can see owes its shape, its balance, and even its existence to it. The mystery of dark matter begins with gravity, that universal sculptor which binds the cosmos together. Astronomers once believed that the stars, planets, and glowing gas made up most of the universe's mass. But as they studied the movement of galaxies, something did not add up. The stars in the outer regions of galaxies moved too fast, faster than could be explained by the visible mass alone. According to the known laws of physics, they should have flown apart, cast out into the void by centrifugal force. Yet they remained bound, spinning steadily, as though held together by an invisible hand. That unseen mass, exerting gravitational pull without emitting light, was the first hint of a hidden universe. Dark matter, as scientists came to call it, makes up roughly 85% of all matter in existence. The stars, the planets, the glowing nebulae, all the luminous things we see are only a small fraction of what truly exists. The rest lies unseen, silent, and mysterious. It does not interact with light, does not reflect, absorb, or emit radiation. We can only infer its presence through its gravitational influence. In a sense, dark matter is the shadow framework of creation, the scaffolding upon which the visible universe is built. Without it, the galaxies would never have formed. Without it, there would be no stars, no worlds, no observers to wonder at the night sky. In the earliest moments of the cosmos, dark matter played the most crucial role in organizing chaos. After the Big Bang, the universe was filled with hot, expanding gas. Ordinary matter, the hydrogen and helium formed in the first minutes of creation, was coupled with radiation, too energetic and diffuse to collapse under gravity. But dark matter, unaffected by radiation, began to clump together almost immediately. It formed halos and filaments that spread through the universe like threads of an unseen tapestry. These structures were the first seeds of form in an otherwise formless cosmos. Over time, they became the gravitational wells into which ordinary matter would fall, eventually giving birth to the first stars and galaxies. Imagine the universe as a vast, invisible web stretching across unimaginable distances. At the intersections of its filaments, dark matter gathered into dense nodes, like knots in a cosmic net. It was at these nodes that gas began to accumulate, cooling and collapsing to form stars. The galaxies that we see today are not scattered randomly throughout space. They are arranged along this web, tracing the invisible geometry of dark matter. What we perceive as clusters and superclusters of galaxies are, in truth, just the glowing highlights of this hidden structure. The bright dust caught in the threads of an immense cosmic fabric. The scale of this structure defies comprehension. Each filament of the dark matter web can spend hundreds of millions of light years, connecting galaxy clusters like beads on an invisible string. Between these filaments lie vast cosmic voids, regions so empty that even light seems reluctant to pass through. The universe, when seen on this grand scale, resembles a living organism, with filaments like arteries and galaxies like cells. And at its heart lies dark matter, the silent pulse of its architecture. Though we cannot see dark matter directly, its influence is written across the sky. When light from distant galaxies travels toward us, it bends around regions of dense dark matter, an effect known as gravitational lensing. By studying these distortions, astronomers can map the invisible landscape of the cosmos. What emerges from these observations is a portrait of an intricate, interconnected universe, one in which the visible is merely the surface layer of a much deeper and older reality. Dark matter, though invisible, gives the cosmos its shape and order. It holds galaxies together like delicate sculptures of gravity, allowing stars to form and life to someday emerge. Yet despite its vast influence, we still do not know what dark matter truly is. Scientists have proposed many possibilities: exotic particles that rarely interact with ordinary matter, remnants from the earliest moments of the Big Bang, or even undiscovered phenomena beyond our current understanding of physics. Experiments deep underground and telescopes scanning the heavens search for its traces, hoping to catch a whisper of its presence. But so far, it remains hidden, elusive, and silent. It is as though the universe keeps this secret close, allowing us to glimpse its structure, but not its substance. The relationship between dark matter and ordinary matter, one of silent cooperation. While dark matter provided the scaffolding, ordinary matter filled in the details. The two are bound together in an eternal partnership, the unseen and the visible, the framework and the flesh. When we look at the Milky Way stretching across the night sky, we are not only seeing the light of billions of stars, but also the hidden hand that shaped them. Every curve of a spiral arm, every cluster of stars, every glowing nebula sits within the gravitational embrace of dark matter. The galaxies do not simply float through space. They move within dark matter halos, vast invisible cocoons that cradle them as they spin through time. In the distant reaches of the universe, where galaxies are still forming, the fingerprints of dark matter can still be seen. Observations reveal young galaxies wrapped in halos of unseen mass, growing and merging under its guidance. Even as the universe expands, dark matter continues to bind these systems together, resisting the pull of cosmic separation. It is the quiet counterbalance to expansion, a force that preserves connection in an ever-widening cosmos. As the universe aged, dark matter's architecture became the foundation for everything that followed. Within its filaments, galaxies formed, merged, and evolved. Stars lived and died, creating the heavier elements necessary for planets and life. The invisible web of dark matter ensured that these processes happened not randomly, but in harmony, creating a universe capable of structure, diversity, and beauty. The very atoms in our bodies trace their lineage back through stars and galaxies to the patterns set by dark matter billions of years ago. It is no exaggeration to say that we exist because of something we cannot see. Every new observation brings us closer to understanding, yet the mystery remains as profound as ever. It is as if the universe is gently reminding us that not everything needs to reveal itself completely, that some parts of creation are meant to remain in quiet shadow, shaping reality from behind the curtain of light. Dark matter is the great unseen foundation of existence. It is the hidden thread that connects galaxies, the silent architect that carved the pathways of light, the invisible partner in the universe's long journey from chaos to structure. Its presence fills the cosmos not with sound or brilliance, but with stability and form. It is the background hum of gravity that holds everything together, the unseen order that gives meaning to the stars. And though we cannot touch it or see it, its influence surrounds us completely, woven into the very fabric of the night sky, holding the universe in balance and giving shape to the cosmic dream. Keynote 6 collisions in slow motion, the dance of galactic merger. Sacris, the vast reaches of the cosmos, where distances are measured in millions of light years and time moves at a scale far beyond human comprehension. Galaxies do not live in stillness. Though they appear frozen to our eyes, suspended like islands of light in the endless sea of darkness, they are always moving, drawn by the invisible hand of gravity. Over billions of years, these colossal systems, each one containing hundreds of billions of stars, approach, intertwine, and merge. Yet unlike the violent imagery that the word collision might suggest, the union of galaxies is a quiet ballet. It unfolds slowly, gracefully, and often in near silence, played out across eons. It is the grand choreography of creation, the cosmic dance that gives rise to new galaxies, new stars, and new beginnings. The story of galactic mergers begins with gravity's ceaseless pull. Every galaxy exists within a vast halo of dark matter, a gravitational cocoon that binds its stars, gas, and dust together. These halos attract one another across the immense gulf of intergalactic space. When two galaxies drift close enough, their halos begin to interact. The gravitational fields stretch and twist, subtly altering their shapes, drawing out long tidal tails of stars that stream into the void. From a human perspective, this process is imperceptibly slow. What appears frozen in one age transforms only slightly in the next. Yet, on the cosmic scale, this is movement, an intricate and patient performance choreographed by the laws of physics. When galaxies collide, they rarely do so with destructive violence. The vast emptiness within them ensures that the stars themselves almost never touch. The distance between stars in a galaxy is so great that even during a merger, the chance of two stars colliding is infinitesimally small. Instead, the forces at play are gravitational immense tides that reshape the structure of galaxies, compressing clouds of gas and igniting new waves of star formation. It is as if the galaxies breathe life into each other, triggering the birth of countless new suns as they merge and reshape. Astronomers have captured glimpses of these events through powerful telescopes, revealing forms both haunting and beautiful. Some galaxies stretch into long, luminous tendrils as they interact, like dancers reaching toward one another. Others swirl into double spirals, their arms twisted and elongated by tidal forces. In some cases, the merging galaxies appear to be embracing two bright cores surrounded by clouds of stars, slowly coalescing into a single glowing heart. These images, frozen in light, are snapshots of processes that take hundreds of millions of years to complete. To the human eye, they are serene, but to the universe, they are the very heartbeat of creation. One of the most famous examples of this cosmic dance is the merging pair known as the antennae galaxies, located about 60 million light-years away in the constellation Corvus. Named for the long, arcing tails of stars that stretch out like delicate antennae, this pair is caught in the midst of collision. Their mutual gravity is tearing at their structures, flinging stars into long trails and compressing gas clouds into dense knots that glow with newborn stars. The result is both chaotic and harmonious destruction and creation unfolding in the same breath. When the merger is complete, the two galaxies will settle into one, larger and more luminous than either alone. A new galactic form born from the quiet clash of giants, our own galaxy. The Milky Way is not exempt from this cosmic destiny. It too is a participant in the long, slow dance of gravity. In about 4 billion years, it will merge with its nearest large neighbor, the Andromeda Galaxy. Even now, Andromeda is approaching us at a speed of roughly 110 kilometers per second, drawn inexorably by the gravitational attraction between the two. When they finally meet, the night sky will transform into a spectacle of unimaginable beauty. For millions of years, the stars of Andromeda will stretch across the heavens, merging with the Milky Way in a slow-motion embrace. Though this may sound cataclysmic, the result will not be destruction. Instead, the two galaxies will combine into a single, massive elliptical galaxy, glowing softly with the light of 1 trillion suns. For any civilizations that may exist, then, it will be a sight of quiet awe, a reminder that even in the vastness of time, nothing in the universe stands still. As galaxies merge, their central black holes, the enormous, invisible anchors at their cores, also spiral toward each other. Over time, these supermassive black holes draw closer until they, too, merge, releasing vast waves of gravitational energy that ripple through spacetime. These waves, known as gravitational waves, are faint but real echoes of the universe's most powerful collisions, now detectable by instruments on Earth. Yet even these mighty events unfold in silence. There is no sound in the vacuum of space, no roar or explosion, only the smooth, rhythmic stretching of space itself, as if the universe whispers the story of its transformation through the very fabric of existence. The merging of galaxies is one of the most profound demonstrations of the universe's dual nature, that creation and destruction are not opposites, but partners in an endless cycle. As two galaxies collide, their original forms may be torn apart, their delicate spirals or disks distorted into strange shapes. But from that chaos comes renewal. The gravitational compression of gas clouds sparks new generations of stars. Old stars are scattered into new patterns, while young ones ignite, illuminating the merging system with fresh brilliance. The galaxies that emerge from these mergers are often larger, more complex, and more diverse than the ones that came before. This is how the universe grows, not through sudden bursts, but through slow, graceful unions. Astronomers studying these mergers have learned that they play a crucial role in galactic evolution. Many of the largest galaxies we see today, the massive ellipticals that dominate galaxy clusters, are the end products of countless mergers. Each encounter added new stars, new elements, and new stories to their structure. In this way, every galaxy is a record of its own history, a layered memory of countless interactions stretching back to the dawn of time. To study a galaxy is to read a biography written in starlight, each cluster, each faint halo, a chapter in its cosmic journey. Though these mergers take billions of years, their beauty transcends time. In observing them, we glimpse both the past and the future of the universe. Every interaction we see in the distant cosmos is a mirror of what has happened and what will happen again. The same forces that drew together the first galaxies still operate today, slowly weaving the universe into larger and more intricate patterns. The cosmic web of dark matter ensures that galaxies do not drift endlessly apart, but instead fall toward one another, merging and reshaping in a slow rhythm that continues without end. To imagine a galactic collision is to imagine time stretched to its furthest limit. What to us would be a momentary event, the crossing of one sky into another, to the universe unfolds with infinite patience. The stars swirl in majestic arcs, nebulae are torn and reformed, and over the course of hundreds of millions of years, a new shape emerges. It is a process too vast to witness in its entirety, yet in its stillness lies a strange serenity. For all its grandeur, it is not chaos, but continuity. The cosmos remaking itself through the dance of its own creations. Even now, in the depths of the night sky, countless mergers are taking place. Some are in their early stages, where two galaxies have just begun to feel each other's pull. Others are deep in the act of merging, their structures entwined and their stars mingling like rivers joining at a confluence. Still others are nearing completion, having settled into a new form that will endure for billions of years to come. Each of these mergers adds to the ongoing story of the universe, a story not of destruction, but of transformation. The dance of galaxies reminds us of the universe's patience, its quiet persistence in creating beauty through motion and time. It teaches that even when forms are lost, their essence continues, reshaped and renewed in endless cycles. Just as the stars within galaxies live, die, and give birth to new generations, so too do the galaxies themselves. The universe does not rush. It moves at the pace of gravity, at the rhythm of eternity, allowing every collision to become a work of art painted across the canvas of space. And somewhere within that endless ballet of light and silence, our own galaxy waits, drifting toward its partner, preparing for the next step in the dance that has been unfolding since the beginning of time. If we travel back far enough, before the Earth, before the Sun, before the spiral arms of the Milky Way even began to glow, we would find ourselves inside vast clouds of gas, the raw material of the cosmos, spread thin across an ocean of dark matter. Within these clouds, under the soft but persistent hand of gravity, stars were born. They lived, they burned, and eventually, they died. Some of them exploded in magnificent supernova, scattering their remains across the interstellar night. Others collapsed quietly, their heavy elements drifting outward, carried by solar winds. These remnants, these atomic fragments of what once burned as suns, became the dust that would one day form planets, oceans, and living things. Every molecule in our bodies, the oxygen we breathe, the calcium in our bones, the iron in our blood, was forged in those ancient furnaces. The story of galaxies, therefore, is not just the story of distant stars. It is the story of us. We are the children of Stardust, the quiet echoes of a cosmic birth that began billions of years before life ever opened its eyes. When the first galaxies formed, they were made almost entirely of hydrogen and helium, the simplest elements born in the first minutes after the Big Bang. They glowed softly with the light of early stars, but they were chemically poor, lacking the heavier elements needed for complexity. As these first stars aged, they became alchemists, fusing lighter atoms into heavier ones in their cores. Carbon, nitrogen, oxygen, silicon, and iron, the ingredients of planets and life, were all created inside stars. When those stars reached the end of their lives, their deaths became acts of creation. The explosions scattered their enriched matter across the galaxy, seeding the interstellar medium with the building blocks of future generations of stars and worlds. Every new generation was richer than the last, each one a little more complex, a little more capable of forming the conditions necessary for life. In the slow unfolding of time, this cycle repeated endlessly. Stars formed, lived, and died, spreading their elements throughout the galaxy. From these remnants, new stars were born, surrounded by swirling disks of gas and dust. Within those disks, matter clumped together, forming planets and moons. The process was slow, almost imperceptible, but constant. The galaxies were not just glowing islands of light. They were cosmic gardens, growing the materials from which life could eventually emerge. And in one quiet corner of one spiral galaxy, around an ordinary star, one small world gathered enough of these cosmic seeds to become a home. When we look at the night sky, we often imagine ourselves as small, isolated observers staring outward at something distant and unreachable. But in truth, the sky is not something separate from us. The same materials that form those stars and galaxies flow through our veins. The iron that gives our blood its color was born in the heart of a dying star. The carbon that forms the backbone of our DNA was once scattered through the arms of an ancient galaxy. The calcium in our bones, the silicon in the rocks beneath our feet, the oxygen that fills our lungs, all of it came from the same cosmic furnaces that light up the night. The atoms that make us are billions of years old, each one carrying within it a record of the universe's long history. We are, in every sense, the universe made conscious of itself. The story of Stardust is the story of transformation. When galaxies were young, the processes that created stars were simple clouds of hydrogen collapsing under gravity. But as stars lived and died, they changed the chemistry of the cosmos. The galaxies became more than collections of light. They became crucibles of evolution. The gas within them was no longer pure hydrogen and helium, but a complex mixture of elements that could form solids, liquids, and the chemical structures of life. Dust grains formed in the atmospheres of red giant stars, drifting through space until they became part of nebulae, the colorful birthplaces of new stars. Within these nebulae, the same elements that once existed in the cores of dying suns began to recycle, binding together in new ways. Over billions of years, this cosmic recycling gave rise to the diversity of matter we know today. Every breath of air is a continuation of that process. The oxygen molecules that fill your lungs may have once existed in a distant part of the galaxy, ejected by a star that died long before the Earth was born. The water that flows through rivers and veins was once ice drifting between the stars. When we touch the soil or watch a flame, we are witnessing the legacy of stellar creation. Even the energy that powers our bodies, the warmth that allows us to move, to think, to feel, comes from the sun, a star continuing the same fusion process that began in the earliest epochs of the universe. In a very real way, every moment of human life is powered by starlight. The galaxies are more than astronomical structures. They are the wombs of existence. Their rotations, their mergers, their cycles of birth and death create the chemistry necessary for life to arise. The story of the Milky Way is a story of continuous creation. For billions of years, it has been forming stars, scattering their ashes, and rebuilding new systems from the dust. The Earth itself formed from one such cloud about 4.6 billion years ago. In that swirling disk of gas and dust around a young sun, particles of cosmic debris collided and stuck together, growing into rocks, then mountains, then worlds. It was from this process, repeated countless times across the galaxy, that planets were born, each one a potential cradle for life, each one a small echo of the galaxy's grand act of creation. The fact that we exist means that somewhere, within this vast cosmic cycle, the conditions aligned perfectly. Our planet cooled enough for oceans to form. Chemical reactions began in those waters, giving rise to the first forms of life. And those living things evolved, carrying forward the atoms of ancient stars in ever more complex arrangements. From the dust of galaxies came creatures capable of thought, emotion, and curiosity. From the fusion of hydrogen and helium came minds capable of asking where they came from. And in that question, our search to understand the cosmos, the universe, reflects upon itself. The quiet birth of galaxies ultimately led to the quiet birth of awareness. When scientists say we are made of stardust, it is not a poetic exaggeration. It is literal truth. The elements of life were born in stars and scattered through galaxies. We are, quite literally, fragments of cosmic history, walking and breathing. Every atom in your body has traveled across unimaginable distances and through countless transformations to arrive at this moment. The carbon in your skin might have come from a supernova in a galaxy now long gone. The calcium in your bones might have once existed in a star that burned when the universe was young. In every human heartbeat, there is a rhythm that echoes the pulse of the galaxies. The galaxies, in their quiet creation, were not only forming stars and planets, they were preparing the ingredients for consciousness itself. Across billions of years, they shaped the environment that would one day give rise to beings capable of wonder. To gaze at the night sky is to look backward through time, and to realize that everything above and within us shares the same origin. The galaxies are not distant strangers, but our ancient ancestors, the vast families of matter and light from which we were born. Even now, the process continues. Stars are still being born in the Milky Way's spiral arms, still dying, still scattering their elements. Somewhere out there, in the glow of a distant nebula, new worlds are forming. Worlds that may one day harbor life. Worlds that will tell their own stories of stardust and time. The quiet birth of galaxies never truly ended. It continues in every atom, every spark, every life. We are a continuation of that process, the living expression of a universe that creates, dissolves, and creates again. Always in silence, always in beauty. Now, in the deep reaches of the universe, far beyond the galaxies we know and name, the process of creation continues in silence. The birth of galaxies is not a story locked in the past. It is an ongoing rhythm, a quiet, ceaseless pulse within the expanding fabric of space. Though billions of years have passed since the first clusters of stars illuminated the cosmic darkness, the same forces that shaped them still work patiently today. The universe, vast and ancient, has not stopped creating. It continues to weave new galaxies from the delicate threads of gas, dust, and gravity, adding new lights to its infinite tapestry. Astronomers peering through powerful telescopes can witness this quiet formation in real time, observing faint, distant smudges of light that are not yet fully formed galaxies, but rather their beginnings, clouds of cold hydrogen gas collapsing under their own weight. These proto-galaxies exist at the edge of what we can see, so distant that their light began its journey toward us billions of years ago. To observe them is to look backward in time, to glimpse the universe as it was when it was still learning how to build itself. Yet even closer to home, in the local universe, new galaxies continue to arise in smaller, quieter ways. When clouds of gas condense in the void between existing galaxies, when dwarf galaxies merge and coalesce, the act of creation renews itself, showing that the cosmos is still alive, still forming, still changing. The birth of a galaxy begins with the same subtle forces that have guided the cosmos since the beginning. Gravity gathering matter, dark matter forming its silent framework, and gas cooling and condensing until stars ignite. Over millions of years, these young galaxies begin to spin, shaping themselves into disks, spheres, or irregular clusters. Each one is unique, a product of its environment and its history. Some will grow large, like the majestic spirals that fill the night sky, while others will remain small and faint, glowing softly at the edges of the universe. But all of them, no matter how vast or humble, share the same cosmic ancestry, born from the quiet interplay of matter and time. Even galaxies that seem old and settled continue to change. They draw in new gas from the intergalactic medium, fueling new generations of stars. They merge with smaller companions, reshaping their forms and reigniting star formation. In this sense, galaxies are never static. They are living systems, growing and evolving through time. The Milky Way itself is not finished. It continues to form new stars, continues to gather matter, continues to transform. In every glowing nebula, in every cluster of young blue stars, the ancient story of galactic birth is being retold. The idea that galaxies are still being born reminds us that the universe is not a completed masterpiece, but a work in progress, a living continuum of creation. It is not a place that was made long ago and left to drift. It is a process that is always unfolding. Every moment, somewhere in the vast darkness, a new galaxy kindles its first light. And in that gentle illumination, the story of the cosmos continues. A story written not in words or sound, but in the quiet brilliance of newly born stars scattered across the infinite night. As our journey through the cosmos draws towards stillness, we are left with the quiet truth that the universe is both ancient and ever new. From the first whispers of light that pierce the primordial darkness to the delicate spirals of galaxies that now float through infinite space, every moment has been a continuation of the same patient creation. Galaxies were not born in chaos, but in calm persistence, sculpted by gravity, guided by invisible webs of dark matter, and illuminated by the fire of newborn stars. In their vastness, galaxies remind us that creation is not a single event, but a timeless process. They are the universe's great storytellers, carrying within them the memory of the Big Bang, the alchemy of stars, and the slow evolution of structure from emptiness. Within their arms, stars live and die, scattering the ingredients of life into the interstellar sea. From their dust, planets form, and from those planets, life eventually emerges, fragile, aware, and capable of wonder. We are not separate from this story. We are its living continuation, the consciousness of galaxies made flesh. When we look up at the night sky, the faint light of distant galaxies crosses billions of years to reach our eyes. Each photon is a message from the past, a silent testimony of creation still unfolding. The universe does not end in darkness. It expands in silence, always becoming, always forming, always creating. The galaxies drift through time as the eternal bloom of the cosmos, quiet, graceful, and infinite, carrying within them not just the birth of stars, but the story of all things that have ever existed, and all things that will ever be.